In this video, we're going to talk about the concepts that are covered in your textbook, Module 14, Section 2. And what we're doing in this section is classifying numbers. We started off in class looking at some different vocabulary terms that are really important in this section. So if you didn't get a chance to copy these down yet, take a minute, pause the video, and go ahead and put them into your notes so that you have them. The 5 words that we're going to be working with are real numbers, rational numbers, irrational numbers, integers, and whole numbers. I think one of the most confusing pieces of this is what's the difference between an integer and a whole number. Those types of numbers do overlap a bit. An integer can be a whole number and they're opposite, so an integer can have a positive or a negative value, whereas a whole number can only be positive. So based on those definitions, we have here kind of a Venn diagram that we can use to kind of see where numbers should fall. So let me get something I can write with. So we know that real numbers are broken into 2 categories. We have our rational numbers, which are the numbers that can be written as fractions. And then we have the irrational numbers, which are the ones that cannot be written as fractions, or the ones that are sort of weird and crazy. The most common example that you're familiar with of irrational numbers is pi. The decimal value for pi is one that continues on forever and ever without making a pattern. Some other irrational numbers are numbers that are square roots. If I'm taking the square root of, say, 17, that number would be irrational because if I find its value, again, it's one of those long, crazy decimals that I would not be able to write as a fraction. Our rational numbers, let's start all the way in the middle here. Our whole numbers can be any positive whole number. So it's a number that does not have a fractional or decimal part. 0 is considered to be a whole number, and any number above that. So I could say 2. I could also say 45. Moving out from whole numbers, we're looking at integers, and an integer sort of overlaps with whole numbers, but it adds to that set all the negative whole numbers. So negative 4 is an integer. Negative 9 is an integer, so on and so forth. Some numbers that are considered rational but that are not considered an integer or a whole number could be a decimal, such as 4.5. It could be a fraction, such as 2/3. It could be a decimal that repeats, such as 0.3, and we'll use the bar notation there. So based on that, we're going to work on classifying some numbers. So if we had the number square root of 5, I'm going to try to classify this in as many of those categories as I can. Now, I know because the square root of 5 is not a perfect square, I'm going to consider it to be an irrational number because I cannot make that decimal into a fraction. If it's irrational, it's also real. And then my other options would be rational, which wouldn't make sense because we already said it's irrational. It's not an integer, and it's definitely not a whole number. So my only 2 classifications would be irrational and real. Another example, if we had the decimal negative 17.84. So the first thing I'm going to ask myself is this number rational or irrational? Can I write it as a fraction or no? And the answer to that would be yes. I could say that this number is 17.84. So that means that this is a rational number. If a number is rational, it is also a real number. It is not an integer because it has a decimal part, and it's not a whole number, again, because it has a decimal part. So those are the only two classifications for this number. And let's look at one more. The square root of 81 divided by 9. And with a situation like this, we're going to try to simplify this number before I classify it. So I know that if I look at the numerator here and I take the square root of 89, 81 is a perfect square. So what number times itself gives me 81? And that would be 9. And then if I simplify the fraction 9 over 9, that would give me 1. So now I'm really classifying the number 1. Well, again, I start by asking, can I write this as a fraction? The answer is yes, I could put it over 1. If my number is rational, it's also real. The number 1 is an integer, and it is also considered to be a whole number.